Hello viewers, welcome to K Diagnostics Duo here. Today we have a 2008 Mercedes GL320 with a 3.0 liter. The customer complaint is that the check engine light is on. And he also stated that when the check engine light came on, the vehicle lost power completely and he couldn't drive it. So he got it on a tow truck and towed it here. It sounds like this vehicle has entered the fail-safe mode, which is also known as the Limp mode. Interestingly enough, this morning when I went outside the shop to get it ready to bring it in the shop, the light was on, but it seemed to drive fine. And then I went around, so I did drive around the shop here, and I noticed it. It feels like the Limp mode is intermittent, so it's losing power here and there. So first things first, let's confirm the customer complaint and then scan it so we can find out what kind of trouble codes we have in memory. So let's go inside the car and confirm and scan it for some trouble codes. So we're inside the car. The first thing I'm gonna do, I'm gonna start it so we can confirm the customer's complaint. So the vehicle is running right now, and as you can see, I'm sorry for that beep, guys. As you can see, the check engine light remained on. So customer's complaint confirmed. So now I'm gonna turn it off so we can connect the scan tool and find out what kind of trouble codes we have in memory. The scan tool is connected, so now let's scan it for trouble codes. I'm just gonna go to the OBD2 generic side of the scanner. I mean, we can do this two ways. I can also go to the OE side, but Snap-on is not the greatest when it comes to European vehicles. Start communication. So we may just be fine by staying on the OBD side, the generic side. So let's go to display trouble codes. And here are trouble codes we have. We have a couple manufacturer specific codes, and based on what the customer said, we're gonna focus on this code right here, this P0245 or this P0299. We will focus on these two trouble codes because remember he said that the car is going on limp mode, so it's losing power. So let's back out of here and learn a little bit about these trouble codes. I mean, it has a couple of trouble codes, but on this video we're just gonna focus on this. Let's pick this one because I believe this one is also causing this one to come up. So if we fix this, that should take care of this first, and then I will address the other ones later. So let's back out of here. Let's find out about this P0299. So let's back out and go to troubleshooter. And the code was P0299. So P02, so right here. So the code is P0299. It should be right here. So P0299. I mean, as you can see, it's the same. Sorry for the glare, guys. So here, so it says P0299 turbocharger / supercharger A underboost condition, and here's the description. This fault code is stored in the engine control module when the actual boost pressure differs from the desired boost pressure. When this fault code is stored, the ECM enters a limited operating strategy. This reduces the boost pressure to minimum to limit the possibility of damage caused by excessive boost pressure. Okay, so I mean, this actually explains what the customer is experiencing. The customer said that the car was was losing power. I mean, it felt like it was just dying. It felt like the car was falling on its face. So when he put it in drive, it wasn't going any faster. So it said he lost power. So let's keep reading. Variable geometry turbocharger. So most systems have a fail-safe function. The function is in a position where it is unable to deliver any measurable boost pressure. When the engine starts, a depression or vacuum is applied to the turbocharger. This causes the vanes in the turbocharger to move to a position where maximum boost pressure can be delivered. As the boost pressure increases, the depression applied to the turbocharger is reduced. This reduces the increase of boost pressure. Oh, I can't read. This reduces the increase of boost pressure as the engine load increases. An electrical or vacuum system failure will result in a loss of boost pressure. So an overboost condition is normally caused by a malfunction within the turbocharger. This malfunction causes the vanes to become stuck in a position which causes the boost pressure to increase. An underboost condition can be caused by a faulty turbo boost control solenoid, leaking vacuum pipes, or an electrical malfunction of the boost pressure control unit. If a vacuum-operated solenoid is used to control the system, a blocked vent can also result in an overboost condition. Where the turbocharger control module is used, an electrical malfunction can cause the actuator to get jammed in one position. Depending on where the actuator jams, the boost pressure can be affected accordingly. Possible causes: mechanical defect. So this is valuable information because by looking at this code and by knowing what causes this code to come up, so it gives us direction. So we have an underboost problem, and according to this, if we have an underboost problem, it's most likely a mechanical issue, so within the actuator system. And this one is actually the actuator of the turbo that moves the vanes inside the turbo are not vacuum operated. So there isn't a vacuum solenoid or a vacuum actuator. So this is actuated electrically. It's got an electrical connector going to the actuator. So what we're gonna do now is, now that we know that this issue is probably, cause I'm saying probably because something else might be the cause, all the mechanical linkages and everything may work well, but if it's jammed in one position, it's still not gonna work. So what we're gonna do is, let's back out of here and look at some live data, because this code sets when the computer looks at the actual boost pressure versus the desired boost pressure. And also a faulty boost pressure sensor can also cause this code. If the boost pressure sensor is not telling the computer what's exactly going on inside the intake, this code can be set as well. So let's look at data, let's look at boost pressure versus actual pressure, and then after that we're gonna go under the hood and see if we can do some checks at the turbo. All right, so we have boost pressure and then intake pressure, and so let me start the car and see. Uh-oh, I thought the battery was quitting on me there. I don't like this discrepancy here between the boost pressure and the intake pressure. As the boost pressure is increasing, the intake pressure should increase too. Do you guys see this number here versus this? All right, so I can take this on a test drive and look at this data pit as I'm driving, but this should be enough info here. When I go to wide open throttle, these numbers should be close to each other. So let's turn off the car first. Let's back out of here, and now let's go under the hood and do a visual inspection and do some checks at the turbo, and then maybe test the boost pressure sensor too. So let's go under the hood. Alright guys, so we are under the car right now, and here is the turbo. So what we're gonna do, we're gonna test two things, because mostly that underboost code is caused by usually two things. It's either the sensor or the sensor wiring. I mean, if the sensor is not reporting to the computer, or the mechanical side of the turbo. So the actuator, the linkage, or the vanes. Sometimes the vanes get stuck or the actuator goes bad. Since this is easy to access, so I'm gonna start here. What we're gonna do is we're gonna disconnect the linkage from the actuator. So here is the turbo positioner. So here's the turbo actuator. I'm trying to get this light to stay, so bear with me guys. Yeah, it's basically an electric actuator. Some of them are vacuum operated, but this one is electric, so it's a little electric motor. So what I'm gonna do is I'm gonna disconnect this linkage here first. It's got a little clip right here, so it's disconnected. I gotta make sure that this linkage is moving freely, and as you can see, it's coming up and down freely. And as I do that, I can actually hear the vanes inside the turbo go up and down, so which is good. We don't have stuck vanes, because if the vanes inside the turbo are stuck, we will have this code. All right, so now that we got the linkage disconnected from the actuator, the next step is going to be checking the actuator. It's a 3-wire actuator. It receives power and ground and then a signal from the ECM. So we have to make sure that we have power and ground going to this little motor here, and also we have to make sure that the signal is making it to this actuator. So let's remove this intake or this air cleaner line off. So I'm gonna get this out so we can get access to the actuator connector, electrical connector. Alright, so we got the air cleaner tube out of the way. I'm gonna disconnect the actuator electrical connector. Okay, so here is the connector to this actuator here. There are two ways we can test this. I can leave it connected and use a scanner to use a bidirectional control test to actuate it, and I can also make sure that it's a 3-wire connector. So this red wire, I don't know if you can see this wire, so this red wire here, this red wire and green tracer is the power supply, and then this brown wire is the ground, and then the green, it looks like green and brown there, is the signal coming from the computer. So let's make sure we have power and ground on these two wires first. So I'm gonna grab my test light. So I have my test light connected to ground. I'm actually gonna go inside the car and turn the key on. So the key is on, test light connected to ground. If I touch this pin right here, I'm not stuffing it, I'm just touching on it, this test light should light. So right here, the test light is lit. So we have power going to our actuator. So now the next thing we're gonna do, we're gonna test this other wire, this brown wire, which is supposed to be a ground. So I'm gonna now switch my test light to battery positive. And as you guys can see, I'm just touching here on the valve cover, my test light is lighting. So now I'm gonna test this second light here, this second wire here, the brown wire, which is supposed to be a ground. So if it's good, if this motor is getting a ground, once I touch it, this test light should light. And as you can see, my test light is lit. So these two wires are good, okay? So the last test, last but not least, is we're gonna test our third wire, which is the control wire. So this is the wire, the signal that comes from the computer to actuate this actuator right here. So what I'm gonna do is I'm gonna get a scanner and use some bi-directional controls to turn this actuator on. Alright, so now I'm gonna use the scanner to test this third wire right here. The computer sends a ground on the signal here to turn this actuator on. So I have my test light connected to battery positive, and then I'm actually just touching on this terminal here. If everything is working fine, when I turn this on, this test light should light. I don't know if you can see, but it's dim, but it's lit. So right there. Okay? So this basically confirms to me that our wiring is good. Another test I can do is I can turn this actuator manually, so I can send power and ground to it and see if I can get it to move. So that's what I'm gonna do next. So here's what I did, guys. I am energizing this actuator manually. So I'm sending power to it because this is a constant power. So I'm actually bypassing this wire here on the connector. So I'm sending power to it, okay, power. And then the brown wire, which is a ground, okay. So just look at it this way. I'm just bypassing these wires, okay. So power, ground, and then the third wire, which is this one, is a ground coming from the computer, okay. So I have power going there, ground. If this motor or the actuator, if this were good, once I connect the ground here, this arm here should spin. See this arm? It's stuck. It should spin. The fact that it's not spinning, this tells me that this motor, this actuator, is defective. And remember when we read on the code description, it said that low boost can be caused by mechanical defect. So this is the mechanical side. If this actuator is just stuck in one position, the boost is not going to increase on the engine. Okay, the vents will not direct the exhaust gases to spin. The vents would not move, which will actually cause the turbo to spin faster. Okay, so right here, I'm sending ground and nothing happens. Okay, let's try that one more time. So ground here, nothing happens. Okay, I'm just bypassing everything. Before I take this out, I'm gonna show you what I'm talking about because I had looked at this already and I ordered this part. I'm not gonna check the boost pressure sensor. I already checked it. I'm not gonna include that part in the video because I checked it and everything checked out okay. The boost pressure sensor is good. So the issue is this actuator. I'm gonna do the same test. I'm gonna manually actuate the new one so you can see the difference. So I'm sending power ground to this. So this arm here is now moving. So let's do the same thing on the new one and see the difference. Alright, so here is the new actuator. And this is the arm I was telling you about. This is the arm that actuates the linkage for the turbo vanes. Okay, so now what I'm gonna do is I'm gonna connect these test leads here to do the same test we did on the actuator that's on the car right now. So I got that connected there, and then this one. Okay, and then the third wire, which is a signal. Okay, so look at that connector this way. So this is going to be that red wire, and then this is going to be the brown wire, and this one here would be that green wire, so the signal wire. So now I'm going to send power here, and then ground here, and then another ground here to see if this arm is going to turn. I did the same thing on the actuator over there. I couldn't get this to turn. So let's do the same thing on this and see if this can turn. If this does, then we will know that that actuator is bad. I got my power going to this connector and then the ground here, and then this is the so this is a ground. So I'm technically being the computer here. So okay, did you guys see that? You see that? You see this one move? Do you see how I'm being able to move this one? But I did the same test on that actuator over there, the one that's on the car. I couldn't get it to move. So this is what the computer does. When the computer wants to increase the boost pressure, it actuates this, which actually closes the vanes or actually moves the position of the vane to increase the boost pressure. So if this motor is bad, the signal is getting there, everything, the wiring is good. I mean, we just checked the wiring. The power is there, the ground is there, and the signal is making it, but the motor is bad, okay? So now what I'm gonna do is I'm gonna remove the old actuator and replace it by this. But while I take it out, we'll do the same test again, just for fun, okay? So let's take that actuator and replace it by this one. Got three 10mm bolts back here. So once I remove these 10mm bolts, this actuator should be able to come out. So I got all the bolts removed, and here comes the actuator. Okay, it's got 3 bolts down here. Okay, 1, 2, 3. All right, so here is the old actuator, and let's do the same test on this actuator. I know it's bad. I already tried that, but let's just double check one more time. So this is gonna go right here, and then this is gonna go right there, and then this one is gonna go right in here. Okay, and then this is gonna be the power supply, power. Then this one is gonna be the ground. So I'm just redoing the same test we did on the good one. And then this is actually going to a ground. I have this test light connected to battery positive. If I touch it, it's gonna light. So we have ground here. So now let's test it and see what happens. All right. So let's test this out. So we have power and ground going to it. So now I'm gonna send ground to this one. And as you guys can see, I'm applying power to it. I mean ground, I'm sorry. I'm applying ground to it. So I'm being the computer right now, so I'm commanding it to move, and as you can see, this arm is not moving, okay? Same thing we did on the other one. So, see? I send power and ground, and then I'm sending a ground as a signal to actuate this actuator, but nothing is happening. And I also don't like the angle at which it's sitting. So right there, this is not working. So one more time, let's do the same test on the new one. So I'm gonna disconnect this. Let's do this really quickly here, just to show you guys one more time. So power here, ground, and then signal here. So now look at the difference, guys. So look at the difference with the new one. Watch this. Do you see that? See right there. See? Right there. Right there. Alright. So that's it, guys. You saw the difference, how I'm able to command this one. I'm able to turn it on, but the other one I can't turn it. So that's the issue, okay? Now I'm gonna install the new one on the car. I'm gonna install it, put everything back together, clear the codes, and then we'll go on a test drive and see. But this is the issue, guys. This is what was causing that limp mode concern to come up, because the engine control module could not increase the boost on the engine. So the boost, so the turbo couldn't spin any faster because of this faulty actuator. So let's install this, and then I'll bring you guys back up. Alright, so I'm gonna install this new actuator. You guys won't see the back here because it's really hidden, and like the bolts are just at the weird angle, so I can't have you guys look at what I'm doing. So I'm gonna put the bolts back on. So these 3 bolts that hold the actuator on the turbo housing. Let's do this first. Alright, so I got all the actuator bolts tightened. So now I'm gonna put the linkage for the vents. Alright, so I got the new actuator installed. So now let's connect the electrical connector for it. Alright, so I got the electrical connector connected back up. So now I'm gonna put everything back together, and then we're gonna go inside the car, erase the code, and test drive it and see how it drives. I got everything put back together. So now let's go inside the car, erase the codes, and then test drive it. Alright guys, so we are back in the car. Let's do our last checks and then go on a test drive. So we're gonna erase our trouble codes. So let's go to engine. Okay. Now let's go to clear codes. So after clearing the codes, the check engine light should go off once we start the car. So I just clear the codes. So now let's start the car and see what happens. Nice. So as you guys can see, the check engine light went off. Okay, the car is running. That's good. So now let's go on a test drive. And we're also gonna be looking at our data pads here. I don't know if I can do that while I'm driving, but we will see. So check engine light is off. So let's make a right here. The good thing is the check engine light is still off, so which is good. So I'm doing about 60 miles per hour right now. You know, before you couldn't drive it this way. You couldn't go up to 60 miles an hour, you know. And when I increase, well, I mean, when I go faster like this, the engine computer actually actuates that actuator, the one we just replaced, to move the position of the vanes inside the turbo so that the turbo can spin faster to increase the boost pressure. Okay, and as the boost pressure increases in the intake, the vehicle goes faster. And with the way I'm driving, you know, I'm slowing down and then picking up. If the issue that caused that underboost code was still there, the check engine light would have come back on by now. I can hear the turbo hissing. So the computer is actuating that actuator, which is changing the position of the vanes. So once those vanes close, so all the exhaust gases get routed to that to the propeller or turbine, and then the turbo spins faster. Okay, so it's getting dark here. It's been a long day. I'm gonna drive back to the shop, and then we can give the customer his car back, and then I will still let him know about this other stuff, that mass airflow sensor code that was coming back up when I cleared the codes. But yeah, so let's go back and be done with this.